Welcome to Spring LIB.
In the first part, we are going to differentiating the wave function equation, which is sinusoidal wave equation. So I can write V is equal to d upon dt or dy upon dt, but we know the wave function equation y is equal to a sine kx plus omega t plus phi. So the differentiation will be equivalent to omega times a cos kx plus omega t plus phi. Now incorporate the trigonometry identity, that is sin square theta plus cos square theta is equal to 1. So to solve this, or to solve for cos kx omega t plus phi, this term I can write as cos kx plus omega t plus phi will be equivalent to square root of 1 minus sine square kx plus omega t plus phi, because we know the general rule, that is cos square x plus sin square x is equal to 1. Now is equal to 1. Now we are going to substitute this cos value in the above equation. So we can get v is equal to omega a, and instead of cos, now I can write 1 minus sine square kx plus omega t plus phi. By solving this, we will able to get v is equal to omega square root of a square minus y square, because y is equal to a square sine square kx plus omega t plus phi. Okay, now we are going to square both the terms or both the sides. So we will able to get the v square is equal to omega square a square minus y square. And by rearranging this term and writing the formula in the form of a, that will be the square root of v square upon omega square plus y square. Okay, now we are going to substitute this equation into the omega form. That means we are having the angular frequency omega 2 pi upon t. This equation we are going to use. So we will have a will be equivalent to square root of v square. Instead of omega, I will write 2 pi upon t, or generally I can write with the direct values, that is v square t square upon 4 pi square plus y square. Now we are going to substitute the numerical values, which are minus 2 square, 0.025 square upon 4 pi square plus 0.02 square. So the answer will be 0.215 meter. Here I kept the unrounded value because it will affect the result of another part. Okay, now let's talk about the second part. Here we are going to substitute x is equal to 0 and t is equal to 0 in the above equation or in the equation of wave function. So so we can find the equation for the velocity for the vertical position, and for this particular element we will able to get y is equal to a sine phi, because here we have put x is equal to 0 and t is equal to 0. So this is the condition. Now we are going to differentiate this equation 1 again with respect to time to obtain the equation for the transverse speed of any element. So v is equal to omega a cos kx plus omega t plus phi. Here also we are going to substitute x is equal to 0 and t is equal to 0 to obtain the transverse speed for this particular element. So the v will be equivalent to omega a cos phi, because here the x is equal to 0 and t is equal to also 0. Now let's divide this equation by the velocity equation, this equation. So we will get the ratio of y by v. So y by v will be equivalent to 1 upon omega tan phi. Now to solve for the phi angle, so I can write phi will be equivalent to tan inverse omega y upon v. Now we are going to substitute again the omega, which is equivalent to 2 pi upon t in this equation, and also we are going to put the numerical values here. So that will be tan inverse. Now instead of omega, that is 2 pi upon t, so 2 pi as it is, y is 0.02 minus 2 and 0.025 pi, sorry, 0.025 plus pi. So the answer will be 1.95 radian. Where we have added pi here in this term, since the tangent is negative in either this second or the fourth quadrant. We determine which quadrant by knowing the sign of the sine and the cosine terms. The function has positive sign, positive vertical position, and negative cosine, negative transverse speed. Hence, the angle is in the second quadrant. Now, in the next part, the maximum transverse speed is the absolute value of the coefficient of the cosine function. So I can write the maximum value is V max is equal to omega A. Again, instead of omega, we will put 2 pi upon t, and with that, we will put the values. So, omega is 2 pi, t is 0.025 in our case, and A is 0.021525. So, the answer will be 5.41 meter per second, which is my Vmax. The wavelength of the sinusoidal wave is found by solving for lambda from the equation that can be written as lambda is equal to v times t, which will give the answer 0.75 meters, because v is already there, t is already there. So all we need to do is just multiply it over here. Then the angular wave number k is found as k is equal to 2 pi upon lambda, 2 pi upon lambda. Now we have lambda already here. So the k value will be equivalent to 8.38 radian per meter. The same as we can find the omega angle of frequency will be 2 pi upon t, and the answer will be 80 pi radian per second. Now we are going to substitute all these a, k, omega, phi values in the wave function equation. So in general, we will have our equation again as, which already we have written over here. This is the equation. So in general, my final equation will be equivalent to, let me write it here, that is y will be equivalent to 0.0215 sine 8.38x plus 80 pi t plus 1.95. So this one will be my y equation.